So this is a presentation completely different than what we've talked. I'm sorry there's no diagrams. Long story short, we're going to go from 0 to RF in 420 seconds. I am Norm. I do RF here at National Instruments, but I've been using LabVIEW since 1998. So for quite a long time, I love what I do. I love LabVIEW. I love tests, but I got hooked on RF, and I have to share my passion with you because Jeremy said I needed to fill a spot. So why not? We're gonna make this thing that is like, yeah, I don't understand wireless. It's weird, it's hard, it's black magic. It is not. So hold on, we're gonna go to warp speed. Oh, I missed it. There we go, passed right by it. So there we go, warp speed, here we go. Now listen, I'm gonna hypnotize you, a little bit of black magic, watch deep into the eyes of this guy. We're gonna go, here we go. All right, so step one, how does RF actually work? I'm gonna actually show a video that I show to people in the class that I teach, play, you slow
up and down, even
there we go. So I'm
with the ball,
mute myself. I thought it was gonna be
the waves.
There you go. So first off, we've all seen something like this in a pond, right? Something goes up and down and the waves go away. But is the water that's next to the ball moving away from the ball at all? No. Quantum mechanics. Anyways, we never know where anything is anyways. But indeed, the ball is going up and down, but which way is the wave going? Away from the thing of interest, right? So indeed, when you have something oscillating in a place and disturbing something, and there's some restorative force trying to bring equilibrium back to something, in this case it's gravity and surface tension, trying to make the water flat once again, you end up with this propagation experience. That indeed is true. Are we all willing to accept this? All together?
Yes.
All right, perfect. Oh shit! Not a slide. All right, so we don't need this. This is that video. There we go. Okay, so most of us in the room have some degree of electrical background. If you don't, what's happening is as we connect and disconnect the battery, there's a change in voltage, and indeed, to a loop that is not even connected to it, there is a response. Some of us may have done experiments over time or run late, but this is true. Are we willing to accept that this happens?
Yes.
Okay, fantastic. Okay, so if you take that concept and you actually, we'll run the video in this one. So this indeed happens here. There's a piece of wire that is not touching it, completely separate. Has an LED hooked up to it. It's a coil of copper next to another coil of copper. And there's a towel on top of it, but somehow it's receiving energy. Something's going through that actual towel itself. And there's energy, there's signal making its way through because that battery is opening and closing left and right. Okay, so we're willing to accept that that's true and not magic.
Yes.
Okay, fantastic. All right, great. Okay, so perfect. So, indeed, what if you were to say, I have something making ripples, but I'm not standing watching that person making the ripples. I'm just this little crosshair out in the distance. What if I were to just look at the water that's immediately beneath me? What do you think I would see over time? I'd probably see the little signal that's happening down there in the bottom. And indeed, if I move closer, it's going to get larger. And there's that. And indeed, if I move further away, indeed, it's going to get smaller. But the signal's still there. You still see the ripples in things, right? Yep. Okay, we're willing to accept that. Okay, well, bringing the ubiquitous sine wave that we're all willing to accept that it has three basic parameters: amplitude, phase, and frequency. Now, this is indeed something that is fundamental to many, many building blocks in the world, whether or not you want to think of it as a phasor or a simple sinusoid versus time. So we have this thing, right? We're looking at this wave underneath us that's just happening versus time. Well, what if the person making that thing originally said, oh, sine wave's great. You can have a sine wave, I can have a sine wave, we're sharing sines, it's good. But what if they say, hey, I can take that amplitude and I can change the amplitude versus time as well? Right? So then what do we have in that scenario? Are we willing to accept the properties of sine wave? Yes. All right, fantastic. I gotta make sure, since it's a tough crowd. All right, so now what if my message was not necessarily the ripples making its way through the fabric of space and time itself? But my message was the thing riding on top of it. I've now allowed for, right? We have the electromagnetic coupling. You believe that not only in water, when I change a signal, it's going to cause these ripples to happen. But we're talking the fabric of space-time itself, but it does the same thing that happens inside of water. It's unbelievable. Gravity waves. There's another one. They move at the speed of light. It keeps going. But now, what if I were to actually filter this signal, and I would only look at the peaks of that wave that the signal is carrying on? Now, all of a sudden, what do you think I have going from point A to point B? Just waves? I have a message. I have information making its way from point A to point B. And believe it or not, there is, in this fabric of space and time itself that goes through each and every one of us, that there's these ripples happening all over the place. Sometimes if you go out to a lake or a river and you just see the surface and it's just kind of all ripply, and it's maybe not even windy outside, but there's maybe people on the water. That's all the waves from everybody that's in the water just constantly going back and forth. If we could see the electromagnetic spectrum that's all around us, we would see a surface like that. But if you knew that somebody was out there putting their message on a carrier, and you could say, I'm going to look for that very specific carrier at this point because I know it's kind of coming out here. And you could say, hey, I'm just going to say, I'm going to see a wave, but I don't care about the existence of the wave. I care about how that wave changes. And how that wave changes is where the message is. Now, this is an analog modulation for this because it's constantly changing. But what if I were to change it to discrete ones and zeros? I don't have that demo for here. Then what would I have? I would have analog, but I would have digital. And I'd have 1G, 2G, 3G, 4G, 5G. There's actually 2.5G and 2.78G. But that doesn't make a difference. We'd have all the guns that we have right now transferring all the kittens of the internet through the air practically at every point in time. And now you understand, indeed, how all of this works. So you've gone from 0 to RF. Hopefully it's no longer black magic. It's a little crazy, but that's okay. If you're passionate about it and want to talk about it some other time, hit me up. I'm Norm. Thanks so much.